Okay guys, so today we're going to talk about light and the parts of the eye and interactions with light. So first off, we're going to do the parts of the eye. Okay, and we're going to start out by making a backwards letter C. And we're doing it that way because we're going to say that our light source is over here. Okay, and so it's going to be producing light this way. So obviously, in order for us to see that light, we're going to have to be looking this way. So now I want you to kind of make like a little bulgy section, so a little bit more than just further continuation of the shape. Okay, and then you can kind of give it a little bit of thickness. Okay, and that is called the cornea. And the cornea is kind of the first line of defense for your eye. That is what protects your eye. It protects all the delicate structures inside. That is the part that your eyelids rest on, that they clean. That is the part that a contact lens would sit on. And if you've ever had a scratch to your eye, you've had a scratch to your cornea, and you know that it is very, very painful. Okay? The cornea is one of the first parts of the eye that focuses the information, the visual information, on the back of the eye, on the retina. Okay? So what happens here is if you have vision issues, it's because the cornea or the lens or some combination of both of them and the shape of the eye is causing that focus to not hit the back of the retina. If you've ever heard of LASIK eye surgery, basically what they can do is they go in and they shave off some of the cornea with lasers to make it so that the cornea is thinner so that it focuses the light differently. Okay? And we'll get into that in a little bit. So what I want you to do here is I want you to give a little kind of horseshoe thing, and then you're going to kind of go around here along the inside of your eye. Okay, and this is going to be representative of the retina. Now the retina does not go the entirety of your eye, it's only near the back side of it. Okay, and so I'm going to represent the retina with these dots. Okay, and the retina is where you are actually getting the visual information that is being transmitted to the brain then. Okay, and so the retina, that is where the rods and the cones are, and we'll get to those in a minute. Okay, now here inside the cornea, you have what we would call the iris and the pupil, and the iris is the colored part of your eye. Okay, it's the part that controls the size of the pupil. And the pupil itself is nothing, it's a hole. But the pupil allows light to come in to the eye. And if it is, let's say it's a very bright light, then it's going to contract the pupil, make the pupil smaller, so less light can get in. If it's very dim light, it's going to dilate or open up that pupil to let more light get in. Okay, so that's the pupil. Okay, and the colored part is the iris. Okay, now much like butterflies and a lot of other things, the structure of the iris is what gives it its color. There's some pigment there, but there are a lot of times where the color is just because of the way the light is reflected and refracted inside your eye. Okay, so now we have light going in through the cornea, through the pupil, and it's going to now be focused by what we would call the lens. Now the lens is something that can kind of change shape. there are little muscles that connect to the lens that can stretches out or relax and let it kind of bunch up. That helps you focus on things that are farther away or closer up. If you've ever seen a camera where it kind of tries to autofocus and it changes, gets blurry and then clear, that's what happens with your eyes, but it happens instantaneously. Okay, so the lens then focuses that light onto the retina at the back. Now, if it focuses it perfectly, then you have great vision and you have no problems at all. But there are also some problems. If your eye is, let's say, a little bit longer shaped, okay, the light might focus in front of the retina, and so that you would have a blurry shape. If your eye is a little bit kind of squished more, the light might focus behind the retina, and you're going to have vision issues that way as well. Okay? Glasses can help that because they can be put in front of the lens to allow the light to be bent before it gets to the cornea, before it gets to the lens, and then before it gets to the retina. The idea is that the light wants to focus on the retina at a very specific point. That is how you see things clearly. Okay? So, now we have the lens. And now inside here, all of this is called vitreous humor. It's a liquid inside of our eyes, but we don't really need to worry about that too much. Now we're going to talk about what's in this part of the retina. And so we're going to zoom in on this part. Okay? And so inside this section of the retina, in most sections of the retina, you are going to have two kinds of cells. You are going to have cone cells that are kind of, well, cone-shaped. And you're going to have rod cells that are hot dog-shaped. Okay? And those deal in different things. Okay, so the cones deal in color. Okay, the cones deal in color. And the colors are red, blue, and green. Okay? So, red, blue, and green are the cones. The rods deal in dim and bright. They are what help you see in the dark. Okay, if you remember from class, we talked about how the pirates use their eye patches and they think they use that as night vision. So that's the same kind of thing. Now, all of these cells, once they are given light, when the light hits them, they convert those into electrical signals. And then just like with your auditory nerve that takes those signals from your cochlea to the brain, we have the optic nerve that takes those up to the brain for processing. And so the brain is where it takes that visual information and converts it into something we can see. In fact, the picture that is projected onto the back of your retina is upside down because of the way the light is bent. Your brain has to actually flip that back right side up. Okay? So that's kind of a crazy thing as well. Okay? So those are the parts of the eye that we're covering. Okay? You got the pupil, you got the cornea, the iris, the optic nerve, the retina, the rods, and the cones. And this one right here, I forgot to label it, is the lens. Okay? So, now we're going to talk about ways that light can interact. Okay, so we're going to go straight on to another page. Now, we have three ways that light can react. We have light can go right through something that is transparent. We'll call this light interactions. Okay, something that's transparent that means you can completely see through it. Something that is translucent you can somewhat see through it. Okay, we'll give a little bit of a watercolor. Oops. We'll give this a little bit of a watercolor. Okay, so you can kind of see through it. It's kind of blurry, but you can still kind of tell that it's there. Okay, and something that is opaque it's pronounced opaque. That's how it's pronounced. Something that's opaque, well, you're not going to be able to see it at all. Okay, it will not allow any light to transmit through there. The example I gave was cellophane, like clear plastic for transparent. For translucent, I gave like wax paper. And for opaque, I gave aluminum foil as an example. You could not tell what the sandwich was like inside aluminum foil. Now we have 4 interactions of light. Okay, the first one we're going to talk about is scattering. Okay, that's when light hits a surface and then it bounces off in all directions. Some of it gets absorbed into the surface, some of it gets spread out in all directions. And that, something called Rayleigh scattering, is what causes the sky to be blue. Okay, now you might think, well, wait a minute, why is the sky blue in the day, but in the evening it's orange and pink and all those colors? Well, here's why. If this is the Earth, and this is our atmosphere, and here's the sun, not to scale, obviously, and you are right here, okay? The light's going to go through the atmosphere, and it's going to go relatively straight. There's a relatively small distance that it goes through the atmosphere. That's going to give the blue light enough time to scatter, but not the other colors of light, okay? As the day goes on and the sun moves, the sun might be over here, okay? And then when that light travels to you, it's traveling through much more of the atmosphere because it's going at an angle. And that gives those other colors of light a chance to scatter as well. And so that's why in the evening or in the morning when the sun is low to the horizon, you see a lot more colors than you do in the middle of the day, okay? That has to do with scattering, okay? Anything that isn't shiny scatters light. If you are wearing a shirt that is red, that means it's scattering the light, but some of that red light is being reflected to your eyes. That's why the shirt looks red to you. It's not that it's reflecting all of the light, but some of it is scattering to a point where you can see it. Okay? The next one is going to be a little bit different. This one is called refraction or refracting. That is when a light goes from one medium to another, in this case air, into, let's say this is a piece of glass, and it bends, and then it comes out going at the same angle that it went in as. A great example of this is if you've ever had a cup of water, okay, and you have a straw in that cup of water, it usually looks like the straw is not connected because when it goes from one medium to another, from the from the liquid of the water to the gas above, it looks like it's broken, fractured, refracted, okay? That's what we talked about the kingfisher in class and the archerfish, how they have to judge for refraction to be able to see exactly where their prey is, okay? The next one we're going to talk about is called reflection or reflecting. Okay? Reflecting is when it goes in and it reflects out. Okay? And the thing is that this is equal to this. This is the angle of incidence, meaning it goes in to the surface, and this is, helpfully enough, the angle of reflection. Okay? So the angle of incidence is equal to the angle of reflection. If you've ever tried to kind of like bounce light from a phone or something into someone's eyes, you know what's going on with the angle of incidence and the angle of reflection. The angle is always going to be the same. It's the same kind of thing with a ball. If you were to throw a ball at a wall in this direction right here, you wouldn't expect it to bounce off like this. You would expect it to bounce kind of like that. Okay? Same kind of thing. And the last one is the simplest of all. This is absorbing. That's when light goes into a surface and it just is absorbed in there. Usually it's transferred to heat. Okay? If you wear a black shirt, a lot of the light is absorbed into your shirt and it heats up. That's what causes it to be uncomfortable. Okay? So those are light interactions that we've been talking about. We got transparent, translucent, and opaque. Those are different types of materials. And the way light can interact with those materials are what we have here. We have scattering, refracting, reflecting, and absorbing. Okay? All right.